our presenter from Japan, did you have any safety incidences during the deconstruction of that building, and were you able to recycle all of the materials that were hauled away by truck?
We planned scaffolding and the building um, closed perfectly by uh, plate all 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 of building
So no,
and
so no any accident or no any incident during your demolition. Well, here ask you during your demolition, anything happened?
and okay
Some casualties, some people got injured or whatever.
no
No, very good.
perfectly safety finished.
Good. Is it recyclable? Does can reuse all this material?
uh, concrete concrete was crushed and
Concrete crashed. Yes.
and reused uh, another project.
Oh, good. Please go.
Good morning. I have a question for Philip Oldfield. We are working on pretty similar topics. The main difference I noticed was that you were referring to embodied carbon, while and other scientists do the same. While I used to prefer embodied energy instead. Uh, Carbon and energy are, it's real. We introduce carbon into the atmosphere in order to produce energy. But I was wondering if there are some pros or cons in using carbon instead of energy. Because from my point of view, let's make an example. In France, most of the aluminium is made, which is produced with electricity, is made using nuclear power that doesn't introduce any carbon emissions into the atmosphere. While, for instance, in Italy, we don't have nuclear plants anymore. But I think our aluminium is as much unsustainable as French's aluminium. So what's the benefit in using carbon instead of energy? That's the bottom line. Thanks.
Hello? Okay. The first part is really that there are a variety of metrics out there available to measure building environmental impact. So a full LCA will go beyond energy, beyond carbon. It will look at resource use. It will look at pollutants into the water. It will look at pollutants into the air. The three main ones people tend to use are, as Dario said, energy, carbon or carbon equivalents, which is the other greenhouse gas emissions as well. There are advantages and disadvantages to each. So you gave a very good example of the impact of aluminium. The reason I use carbon is because CO2 has a direct impact on the environment. It is the key greenhouse gas emission, and it has the largest impact on global warming, for example. It's the metric which all global warming potential is measured against. But we are at a stage really where this is an emerging, we both look at similar subjects, and it is an emerging kind of methodology. It's an emerging area of environmental science, and there is still discussion and debate to which metric is most appropriate. So I can see advantages and disadvantages to both. As I say, the main reason I use carbon is because of its impact on greenhouse gas emissions.
Any question? Actually, I have one question for Mr. Huang. Yes, I realize this project have a so thick steel, like a 120. That's thick. You have lots of weld. So I saw you have two type of connection, weld and a bolt. So I saw lots of weld happen in the factory. So my question is, does there any field weld for this such a thick steel on site? I mean the field weld, not shot weld. if you have a fuel weld, how do you control the quality? Fuel 就现场焊 fuel weld. Do you have such a fuel weld for such a thick plates on site? 就是你有这么厚的板，大部分的那个焊接都在厂里做好了，上了有 bolt 接。那么有没有在现场？
The chairman is explaining his question in Chinese.
The quality care， 你怎么控制它的质量？因为这么厚的板，要焊那么大的焊缝，这个
How to control the quality on the site?
我们的第一个原则还是
The first principle is that we'll try to do the welding in the factories, and we are concerned that we might have some deviation. So for some of them, we'll also do the welding rather than the bolting. For this 120 millimeter steel plate, how can we control the welding? How can we prevent the cracking? First, we look at the raw material, and the carbon content or carbon equivalent should be low. And secondly, we have a requirement. We have this kind of the 35 kind of material. And during the welding process, we also achieved some optimization. This section should be minimized. Then the energy should be minimized. And we also do the preheating, especially in winter. This is a very desirable method. If you do not do the preheating for this plate with a thickness of 120 meters, it might result in the cracking. We will do the preheating to 80 degrees Celsius, etc. And we also discussed the other welding methods from bottom to the top. For this 3.7 meters of the welding, we'll have two operators to do the welding simultaneously, and we have the multi-layer welding for this 120 millimeters. Maybe we will divide into 10 layers so that we'll try to prevent and control the cracking.
We have a very good carbon analysis, as I mentioned to you. So any like lead criteria, they adopt your carbon analysis. They set the criteria, or because it's so complicated. Depend on time, depend on material, depend on operating usage. Yeah, it's very complicated. So my question is, how the lead in British, they have their own criteria.
Yeah.
How they adopt your analysis into the code or something quantify?
That's a good question. We are seeing kind of building rating systems start to adopt examining embodied carbon as well as just operational. So I know in Singapore, for example, Green Star, Green Mark, has just started to consider taking this kind of thing on. A lot of people do think it is a complicated procedure, but there are databases available to assist with it. So a lot of my calculations use something called the inventory of carbon and energy, and that has good metrics for the embodied energy of materials, lots of different materials, up until the end of the factory, beyond which you calculate a bit of transportation energy, a bit of construction energy. But what the main reason why life cycle analysis happens in, for example, the automobile industry, product design, is that every product, every car is the same. So you measure one, you measure them all. Buildings have 20,000 plus components. Tall buildings, I mean, the Shanghai Tower must have so many unique components from all around the world. How do you measure all the energy and carbon involved in that? And the answer is it's very difficult. It's very difficult. And it's only now that methodologies are becoming more common, as it becomes a more kind of well-researched topic, that we're starting to get underneath the skin and to realize how to do these calculations. I know Lead, for example, as well is starting to consider this. BREEAM, the British version, has got its own kind of methodology for calculating something called the Green Data Book, where you can look at different materials and it gives you different values. It grades different materials A, B, C, D based on how sustainable they are and how what their embodied carbon is like. So it's an emerging kind of field, really. Hopefully, in 10 years' time, it will be a common piece of analysis when we design buildings, and we will look at life cycle rather than just operational.
Mr. Oldfield, about 5 years ago, many architects like AIA, we pledged that by 2030, carbon neutral buildings. I don't even know how to monitor myself. Is that achievable?
My concern with carbon neutrality is it only concerns one aspect of the building's life cycle. So you can imagine a tall building, which is carbon neutral. Imagine covering a tall building in wind turbines, hundreds and hundreds of wind turbines, so that they generate all the building's energy. That building would be carbon neutral. It would not be sustainable. Its life cycle or embodied energy would be vast. I mean, I've seen studies for wind turbines placed on top of tall buildings where they only generate enough energy to offset the embodied energy of their materials and the extra structure in 50 years. So it takes them 50 years to generate enough energy to offset the initial energy. And I think we can, using recycled materials or structural optimization doesn't have the same bling or the same big visual effect as sticking a great big wind turbine on top of the building. But its impact on the building sustainability will be much better, much greater. And it's about marketing, it's about greenwash as well, and it's this visual, buildings look greener with these massive big technologies on them, and we don't necessarily need that. They are useful, they play a role, but we have to consider the bigger picture. As to carbon neutrality, well, there are examples of carbon neutral buildings, I think, out there, some, multi-story ones, but the term carbon neutrality should be expanded to consider the entire life cycle, I believe. I think the terminology is wrong.